So yesterday you were looking at what really happens in a reaction compared to like the perfect world that we've really been assuming all along. So we said we started off with 36 slices of bread. Now I told you that we had a huge container of ham and we had a huge container of cheese. Now, what can we take away from that piece of information? It means that the bread here is going to be our limiting reagent. When a problem tells you that you have excess something, it means that you have enough of that something to complete the reaction. It is a sign that that substance is absolutely not your limiting reagent. So we were told 36 slices of bread, that's going to be our limiting reagent. Now, based on the reaction that we had, the formula, you knew that you should have gotten 18 sandwiches. Well, lo and behold, when you turned around and counted them, you only had 16 sandwiches. Now, what happened to those other 2 sandwiches? Sometimes kids have a hard time with this, and they give me some crazy answers. But if you didn't figure it out by now, what happened to those other 2 sandwiches? Well, there's 11 other people in this household. Someone walked through and stole 2 sandwiches. Now, that's not obviously what happens in our actual reaction, but sometimes the reaction does kind of steal some of our product and we don't get it all back. So then we wanted to calculate what our percent yield was. And again, percent yield is a percentage that tells us how much product we got compared to how much we should have gotten. Now, common sense here, if we really concentrate and think through what this is telling us and what it should be, you should never get more than 100% yield. Now, sometimes you will, because there might be some impurities in there. More than 100% yield means that whatever you're weighing, whatever you think is your product, is not pure product. There's extra stuff in there. But assuming that there's not, you should always end up with less than you started with, because you can't make mass. You can't suddenly produce more stuff. And just like this, you would never have gotten all of a sudden had 19 sandwiches or gotten 125% of what you thought you were going to get here. Okay, you had, backing up. We said this up here is called a theoretical. It's what we expected. It's what we calculated. Okay. Whereas this is our experimental. We did an experiment. We did a reaction and we got 16 sandwiches out of a reaction somehow. So how do we calculate a percent? Well, percent is always a division problem. In order to get less than 100% yield, which way are we going to have to divide? Well, you're going to have to take your experimental, okay, divided by, we're going to abbreviate, your theoretical. Okay, so we would have taken 16 sandwiches, we're going to abbreviate that too, divided by 18 sandwiches, and you would have gotten 88.88, and so on. Oops. Percent, right? Okay, so how do we translate this back to actual chemicals? Well, basically we do the same thing. You calculated the number of sandwiches you got from this 36 slices of bread. You knew how many sandwiches you ended up with, and we needed to figure out how many we should have gotten. So this type of problem, you're going to be given 2 numbers, just like you were in the limiting reagent problem, except this time you're going to be given a reactant. This is how much you started with, and a product. This is how much we actually ended up with in our lab. And you'll need to calculate what percent you should have gotten. Now, a quick note back. We've seen something similar to this before. This is essentially a calculation that tells us how wrong we were. In the past, we have calculated percent error. These are very, very similar problems. The difference is, instead of taking simply the experimental divided by the theoretical, we said the accepted minus that experimental, we'll abbreviate that, okay, divided by our accepted. Well, what's the difference between an accepted value and a theoretical value? Well, a theoretical value is a calculated thing based on this specific reaction. An accepted value is a number that you can like go look up in a textbook. So if we were calculating the density of a substance, we should probably use percent error. There is an accepted density for a particular substance. But if we're doing a reaction and we want to know how much we got back out of it, that's where we use percent yield. So you'll remember the last lab we did with the zinc and the hydrochloric acid. That's the problem we're about to do here in a minute. We calculated a percent error because we didn't know what percent yield was at that point in time. And some of you were confused as to which value is accepted, which value is experimental, because frankly, they're both experimental. Neither of them is truly an accepted value. Well, what you actually had was you calculated a theoretical, and then when we weighted at the end, that was really our experimental value. It would have made more sense to do a percent yield calculation, but again, we weren't there yet. We didn't have this. So percent error we typically use when you have a value that is set in stone what you're supposed to be doing. Percent yield is what we use when you are doing a situation like our zinc and our hydrochloric acid. You know how much you started with, and you're trying to find how much you end with. Okay, the best you can possibly get is 100%, right? But if you had 100% error, you would have been pretty upset with yourself. Because of this subtraction here, the best percent error you can get is 0. So we aim for no error and lots of yield. Okay, so how do we solve these problems? Again, it's going to look like that, where we've got two values. Okay. And then the question will actually ask, what is my percent yield? These problems are easy to find. It's got right in the question. If you look at our two values, one of them is a reactant. This is how much I started with. This is what I put in. Okay. And one of them is a product. This is how much I really did. So what do I need? Well, I need a theoretical and I need a experimental. Okay. Theoretical is a calculated value. We have done no calculations at this point, so we don't have this. Experimental is something we got out of an experiment, so I have to have told you that we actually did this experiment and given you value. Experimental will always be right in the problem. It'll be a product, okay, right in the question. So that's 1.73 grams of zinc chloride, where our theoretical is how much zinc chloride should we have gotten. Okay, and we can calculate that based on this value for zinc. So I have 0.98 grams of zinc, and I have written and balanced your reaction for you. Okay, this is going to be 65.4 grams zinc rounded, 1 mole of zinc. Okay, this converts us to moles of zinc. Most of you are doing a really good job at this point. Okay, how do we get to moles of zinc chloride? We use up here 1 mole zinc to 1 mole zinc chloride. Okay, and then we need to get so that the units match here. So I'm going to need grams of zinc chloride. So 1 mole of zinc chloride will equal 136.3 grams zinc chloride. And, pardon me while I go get the calculator. We're going to multiply across. We're going to divide by the bottom. Okay, and we'll get 0.98 divided by 65.4 times 136.3. Okay, we get 2.0, we'll keep the 4, grams zinc chloride. Okay. That's our theoretical value, 2.04 grams. Okay, so to calculate percent yield equals our experimental over theoretical. So that is 0.73 grams zinc chloride divided by 2.04 grams zinc chloride. Okay, calculator here, 1.73 divided by 2.04. Okay, and our calculator tells us 0.848, but we know that percentages need to be multiplied by 100 or move the decimal over twice, so we get 84.8% is our yield. Okay, so some things that could have happened to make this not be 100%. You may not have, if we tried to transfer it from one point to another, you might not have transferred it all. Remember that this boiled really hard when we evaporated off all the extra liquid, so maybe some popped out there. There are a lot of different things, and that's where our experimental error that we've been working on all year comes along, is what does it take, what happened to this to make this be less than 100%. Okay, but in the long run, we solve these problems by the experimental value will always be in the problem. Okay, this is given to you every time. The theoretical value is calculated just like we've always done. How much should you have gotten? Okay, and then we take experimental divided by theoretical. Remember to multiply by 100% to get your percentage. Okay, there's 2 problems in the classroom to practice for you, so good luck.